All right, so recording has been started. So in section 2.2, section 2.2 contains finding A inverse, right, by row reduction algorithm, by row reduction algorithm. Uh, they also call it Gaussian Gauss-Jordan method. Gauss-Jordan method is basically used to solve the system of equations. So sometimes we don't call it that way. So anyway, both use row reduction basically. So what we do here is we write a matrix A with matrix identity. Whatever matrix A is given, you write there, here, right? And then you write a identity matrix with it. Okay, A with identity. And then you use row operations to convert this identity matrix to A matrix to identity matrix and use the same operations on identity matrix, and this will become A inverse. The second thing in this section was a solution of system of linear equations using the inverse. So if A inverse exists, if there is an inverse of A, then the solution of the matrix equation is x equal to A inverse B. You just have to multiply. You can just bring this A to the right hand side and multiply by A inverse. Okay. Why? Because you can, when if you multiply A inverse on both sides, AX equal to A inverse B, right? You multiplied A inverse on both sides. This A and A inverse becomes identity. So identity with X just gives you X on the left, and right side becomes A inverse B. So that gives you the solution. Okay. So you don't have to do that. You can directly write this one using A inverse, how to find the solution. Okay. So you can say that this is finding solution using inverse method or inverse of A. So using inverse of A, how you can find the solution. So this is the second thing in this section. The first thing was finding A inverse basically. So if I show you, you can do question number any question from here. Question number 29 will be very easy. 1, 2, 4, 7. You see, if A is 1, 2, 4, 7. You know, in 2.2, they give you direct method for that as well. Direct method is 1 over determinant of A, which is 7 into 1 minus 4 into 2. So 7 minus 8, that is the determinant. And then you just interchange the diagonal elements, 7 and 1, they interchange the places, and you change the sign of off diagonal elements. So 2 by 2 is very easy. This is minus 1. So if you multiply minus 1 inside, you will get minus 7 to 4 minus 1. That is your inverse. But let's say using that algorithm, using the row reduction algorithm, let's see if I can find the same inverse or not. So what we do, we write A with identity. So 1, 2, 4, 7 and 1, 0, 0, 1, same size. Now using this 1, right, I need to make this 0 because I have to make it identity. So I can say R2 minus 4 R1, because if I multiply this by minus 4 and add here, it will become 0, right? So this gives you 1, 2, 1, 0. First equation as it is, 1, 2, 1, 0. 4 minus 4 will become 0, and 7 minus 8 will become minus 1, because minus 4 to the minus 8 plus 7. And then -4 plus 0 gives you -4 and 1 remains as it. Now I need 1 here, right? So I can multiply second row by -1. So if I do that, I got 1, 2, 1, 0, 0, 1, 4, -1. Now I got 1 here, so I can use this 1 to make this 0. How can I do that? You can multiply this by -2 and add here, right? So this gives you, let's say, R1 -2 R2. So this gives you 0, 1, 4 -1. This is second. Now we multiplied this by 2. -2 into 1 is -2 plus 2 gives you 0. -2 into 8 is 4 is -8 plus 1 is -7. And -2 into -1 is 2 plus 0 is 2. Right? So see, is it the same thing? So this is equal to identity. We said that when this becomes identity, the second part is automatically A inverse. So therefore, I will write A inverse separately. Therefore, A inverse is -7, 2, 4, -1. So you can compare it is the same thing that we got at the top from the other formula. So both gives you the same thing. You see, this one and this one. -7 to 4 -1. So this is the algorithm that we use here. And let's say if a system of equation is given and they ask you to solve it, let's say example is solve AX equal to B, right? Where A is the same matrix which I used, 1, 2, 4, 7. That was that. 1, 2, 4, 7. And let's say B is some vector given. Any vector, let's say 2 -5. Right? So if I do that, then we know that solution A is A inverse B, if A inverse exists. So now what is inverse? I just found the inverse. Inverse is -7 to 4 -7 to 4 -1. And I will multiply this by B, 2 -5. So see, we multiplied, this is my A inverse, and this is my B. So if you multiply these two, you will get the answer. So this is minus first row with first column. So -7 into -2 plus 2 and plus 2 into -5. Then 4 into 2, second row into first column and -1 into -5. Plus -1 into -5. Okay, so this has come out to be 7 into -2, 14, -10, -24, and 8 plus 10, 18. So that's your answer. So x is equal to that. X is x1, x2. So you can say that the first one is x, x1 is -24, x2 is 18. Okay, so that is your solution. So using inverse, finding the solution is so easy. So I may give you a matrix A and ask you to use row reduction algorithm to find the A inverse. So you will use this row reduction algorithm. Using algorithm, you will find the inverse, right? And after finding the inverse, if I ask you to use this inverse now to solve a system AX equal to B, you will just multiply A inverse with the right hand side of the system to get the solution. So see example 3 and example 4 on handouts. Determinants with the name of determinants, because in the determinants we studied finding the inverse by cofactor method. So I did 2 examples with this method as well on Moodle. So I just showed you that, right? So on Moodle, if you go to the determinants notes handouts, these are not from the book. These are separate notes. You see here, determinants. If you click on the determinants, go down, inverse of the matrix. This is the inverse using a joint, but this is 3.3. Okay, but we have another method. So writing A with identity transforming A to identity, then identity will become A inverse. So two examples are done here. You can see these two examples. They will be good practice for you. Uh, you have done 3.1, 3.2. So I said one question from this, right? Of this form. One question from 2.2. In chapter 3, we have determinants. 3.1 plus 3.2. We asked in the quiz that how to find determinants, right? So you should know that. Even if I don't ask you any question from here, because in 3.3 you have to find determinants, so you should know that. And then in 3.3 you have one question from here, two questions, not one, right? Two questions from here. One is finding A inverse using determinants, cofactors basically, or you can say that using adjugate of A, or you can say that or using determinants. Everything is the same, because finding adjugate cofactors, they are all use determinants. So if I say find A inverse using the cofactors of A or adjugate of A or determinants of A, it's the same thing, right? And the second thing here was Cramer's rule to solve system of linear equations. They both use determinants. Linear system. So we, if any matrix is written, a matrix is given A11, A12, so on, right? A21, 22, so on, A31, so on. So cofactor is, if I'm taking the cofactor of any, let's say cofactor of this A22, you remove the row, second row, you remove the column. And whatever is left, right? Let's say, right? So if you remove these two columns, you will be left with only A11, A12 is gone, A13, A21, 31, and 33, right? Because this whole row and this whole column is gone. So you got A11, 13, 31, 33, right? So this is called a minor of a matrix, which is called A22. A22 means second row and second column is removed. Row 2 and column 2 are removed. Okay. And if you find the determinant of this A22, right, this gives you C22, which is called the cofactor. So this is called the cofactor of A22, of this number A22. So if I write Aij, Cij, right? So it means it takes the sign as well, I plus j. It takes the determinant of Aij, where ith row and jth column is removed. This is called the cofactor of Aij. So you have to find all the cofactors of the matrix. So then you write a matrix C, which is called a cofactor matrix, C11, C12, C13, C21, C22, C23, because you have all the cofactors, 32, 33, so on, right? So this is called cofactor matrix. And if you take the transpose of this one, that is called the adjoint of matrix. So adjugate of A is the transpose of this cofactor. You can directly write this as well. From the cofactors, if you want, you can directly write, means you can skip this. If you want, you can skip, right? The first row, which is C11, 12, 13, just write it as first column. 21, 22, 23, you can write the second column. 31, 32, 33, you can write the third column, and so on, right? If you want, you can directly write this. This is called the adjugate or adjoint. This book call it adjugate of A or adjoint of A. So if you have this one, then your inverse of the matrix A inverse is 1 over determinant of A into adjugate of A. So you got the matrix adjugate, divide this matrix by the determinant, that gives you the inverse of the matrix. So you should know that. If I go to your assignment that I just downloaded, not assignment, the determinants, this one here. So before that, if you look at this one, this is that method. Example 2. Example 2 in the example 1 and 2, right? They are. So here I think in the typing, these are the cofactors. So cofactors are basically C1112, not A1112. So these should be C. Okay, C11, C12, C13. Cofactors are C, C, C. Let me see if I can open this. Uh, I can do it here. Let's see. If you have to find the inverse of this using adjoint matrix, what you will do, you will first of all, you will find the determinant of A. Okay. 2, 3, 4, 4, 3, 1, 1, 2, 4. Let's do it here. Four, 1, 4. I think this is 2, 4, 1. So anyway, first thing is determinant of A. If determinant of A is 0, there is no inverse. Okay. So this should be non-zero. So you can pick any row, any column. So let's see if I pick first row, right? Then 2 with plus, 3 with minus, 4 with plus. So I will write, let's say this is the blue one, 2. So 2 and remove this row and this column, right? So you have this matrix. Find the determinant of that. 4 3s are 12 minus 2. And then plus minus 3. This row and this column is gone. So now you have 4 1. I can write this 4 1 1 4. Right? And then let's say this orange, this one. So plus 4. And now this row and this column is gone. So you got 4 3 1 2. So in 2, it was when this row and this column is gone 3 1 2 4. This is what you have. Okay. So now if you simplify, this is 2 into 4, 3 are 12 minus 2 minus 3 into 16 minus 1. This is 16 minus 1 plus 4 into 4 to the 8 minus 3. So you got 20 minus 45 plus 20, 20 plus 20, 40 minus 45 is 45, which is not equal to 0. So determinant not equal to 0 means A inverse exists, right? If it is 0, don't go ahead, stop. You can say that there is no inverse of the matrix. Let me check if the inverse is correct. Inverse is minus 5, right? So that's correct. All right, so now cofactors. So again, let me cofactor C11. C11 means first row, first column gone. So it is 3, 1, 2, 4. So 12 minus 2, 10. Then C12. C12 gets a minus sign because whenever you see power is odd, whenever this power is odd, you get a minus sign. It's minus 1 to the power 1 plus I plus j. So whenever I plus j is odd, you get minus, even you get plus. So that's why C11 gets plus. This is even, right? 1 plus 1 is equal to 2, even. So you get plus here. 1 plus 2 is odd, 3, odd. So you get minus sign. So just remember that. So now for second one, 4114. So that is 16 minus 115, but with a minus sign. And then C13. C13 is again plus, and that is 4312. 8 minus 3, 5. So now C21. These three cofactors are exactly here. C11, 1, 2, 1, 3 are here. You see, C11, C12, C13 with a minus sign. Of course, with this minus sign, they are C11, C12, 1, 3. So I have these three cofactors already there. But now C21. So let me 2 minus 3, 4, 4, 3, 1, 1, 2, 4. This was my matrix. Because I have done a lot of work on the matrix, you can use pencil and keep removing the lines. Once you've done one of them, keep removing the lines. So C21 is this now, second row, first column. So remove this line, this. So you will get minus sign because 2 plus 1 is odd, minus sign. So now minus 3, 4, 2, 4. Right? So that is minus 12, minus 8, minus 20, but minus is outside, so 20. Then C22 is plus. 22 means this one, right? So this row, this column is gone. So 2, 4, 1, 4. 2, 4, this is 1, right? 2, 4, 1, 4. So you can use the pencil here and remove the lines, then go to the next one so that you don't have to write 8 minus 4 is 4. Then C 2, 3. 2, 3 will give you minus sign. Right? So 2, 3 is this. So now this row is this column is gone. So 2 minus 3, 1, 2. 2 minus 3, 1, 2. So that is 4 plus 3, 7. So minus 7. And then C 3, 1. 3, 1 is plus. 3, 2 is minus. 3, 3 is again plus. Right? So 3, 2 is, if I again What was my matrix? 2 minus 3, 4, 4, 1. 4, 3, 1, 1 to 4. Now the third line, 1. So this row, this column is gone. So 3, 4, 3, 1. So 3 minus 12 minus 9. Then 2, 2. This is gone now. So 2, 4, 4, 1. See this one. For this one, this is gone. So 2, 4, 4, 1. So that is 2 minus 16 minus 14. So minus makes it plus 14. Then 3, 3 is this is gone. So 2 minus 3, 4, 3. So that is 6 plus 12, 18. Let's check if it is correct. No, this is not there. Did I pick the same? See, I did not pick the same thing. So this is different. What I wrote over there is 2 minus 3, 4. I don't know why I'm using minus 3. No, but my determinant was correct. So it should be the correct matrix. 2, 3, 4, 4, 3, 1. 2, 3, 4, 4, 3, 1, 1, 2, 4. I think the mistake that I did here is um, this is not minus, this is just 3. This is 3, right? This is 2, 3, 4. And this was 3, 4, 3, 1. And this is 1, 2, 4. So it means this 3 was not minus. So that is 12 minus 8, 4. So this is minus 4. And then this 3 is not minus. So 4 minus 3 is 1. So that is minus 1. This 3 is not minus. So 12 minus 12. 6 minus 12 is minus 6. Now I think it's correct. Now if I compare my answers, 10, 15, 5, 10, 15, 5, and minus 4, 4, minus 1. Yes. And 9, minus 9, 14, minus 6. Yes, now it's correct. So therefore, I can write the educate. If you directly want to, if you want to write C first, then you will write in rows. 10, 15, 5 will be a row. If you want to write adjoint directly, you can write this in column. So see 10 minus 15, 5. Minus 4, 4 minus 1. Minus 9, 14 minus 6. So from here, I can write the adjoint or adjugate of A as the transpose of coefficient matrix. So you can write 10 minus 15, 5, minus 4, 4, minus 1, minus 9, 14, minus 6. So that's the adjugate. And then just divide by the determinant. Determinant was 5. You see here, the determinant was 5. So I can divide by. So hence, the inverse of A is 1 over DET adjoint. So that is 1 over minus 5. 5 or minus 5? Minus 5. And this matrix here. So it means I'm dividing every number by 5. So 10 by minus 5 is minus 2. 4 by 5. 9 by 5. 15 by 5 is 3. Then minus 4 by 5. Then minus 14 by 5. 5 by 5 is minus 1. Then minus 1 by minus 5 and minus 6 by minus. So that's the inverse of that. Okay. Whenever you find the inverse by any method, there is a check which is optional, but it's better to do that. There is a check, it's optional for you, but what we can do is we can multiply A with A inverse. So you write your matrix A multiply by A inverse. Okay. Let's take the first row, multiply with the first column, first row, second column, first row, third column. Similarly, second row, first column, second row. So if you multiply rows with all the columns, you should get identity matrix. 1 0 0 0 1 0 0 0. If you are not getting this, it means the inverse is wrong. Okay, so this should give you identity matrix. If it is not an identity matrix, it's wrong. But if it, then you can go back and check, maybe some of your cofactors are wrong or whatever. Okay, for example, the first row is 2 3 4. So if I multiply 2 3 4, this is 2 3 4, and this is minus 2 3 1. So let's multiply minus 1. 2 into minus 2 is minus 4. 3 into 3 is 9, and minus 4 into minus 1 is 4. So see, 9 minus 4 is 1. This is equal to 1. So the first number is correct. Multiply this with the second row, you will get 0. Third row with the 0, and so on. You can complete this. The third thing here is the second thing here was the Cramer's rule. Cramer's rule is used for AX equal to B. Again, the linear system, when your determinant of A is not equal to 0, means when A is invertible. Okay, that is A is invertible. A has an inverse. If A is invertible, then you can use Cramer's rule. Otherwise, you cannot use it. So um, we define here, let's say your matrix A, the first column is, let's say, called A1. The second column is A2, so on, right? Last column is, let's say, AN. We define a matrix AIB where the ith column is replaced by B. A1 as it is, A2 as it is. Ith column is replaced by B, and then at the end. So this is the ith column. Ith column of A, of a matrix A, is replaced by B. So basically, if I write A1B, it means the first column will be B and the second column will be A2, A3, so on, right? Yeah. If I write A2B, it means the first column is as it is A1, second is B, and third as it is A3. So A2 is replaced by B, and so on. Okay, so that's how we can define that. Then find the determinants. Then the solution, Cramer's rule says that your first x1 will be equal to determinant of A1B divided by A, determinant of A. X2 will be determinant of A2B divided by A. So very easy method. X3 will be determinant of A3 divided by A, and so on. So you can find all the numbers like that. This is chapter 3. Look at this one. Right? This is the Cramer's rule that I said. Column I is replaced by B. Then Xi is determinant of AI by A. So if A is 1, I is 1, A1, I is 2, A2, and so on. So look at this one. Very simple method. First of all, if a system is given, you will write the coefficient matrix only. 3, 2, 5, 4. So see, 3, 2, 5, 4 is a coefficient matrix. From there, you can define A, because there are only two columns here. So only A1 and A2 will be there. If there are third column, then there will be A3. So see, this is B, right hand side. So right hand side is replaced here, first column. And for 2, right hand side is replaced in the second column. See? So now find the determinants of all of them. So determinant of A1B is 24 plus 16. So see, 24 plus 16 divided by determinant of this is 12 minus 10, which is minus 12 minus 10, which is 2, right? So determinant of A is 2. So that goes in the denominator too. In the denominator, it's determinant of A. But now what is the determinant of this? 8 3 are 24 plus 30. So 24 plus 30 is 54. So 54 divided by 2 is 27, and this is 20. A very simple method, Cramer's rule. You at the end, whenever you get a solution, you can replace this solution by you can replace this solution in the left hand side. You should get the right hand side 6 and 8. See example 1 on page 180. So 2 questions from here, 3 questions, then 1 from the eigenvalues, eigenvectors, chapter 5. In chapter 5, we did 5.123 and complex numbers as well. But finding the eigenvalues, eigenvectors are given in 5.1 and 2, right? So 5.1 and 2 only has how to find if a matrix A is given, right? How to find eigenvalues and eigenvectors. So eigenvalues and eigenvectors are this one. If I multiply A with X, it should give you some number times the same vector X back. If this thing happens, then X is an eigenvector for some non-zero X. Lambda can be 0, but X has to be non-zero. Then this X is an eigenvector and lambda is eigenvalue. Okay. How to find them? If a vector, if a matrix is given, for example, in the assignment, I think there was the assignment here. Let's say this one, right? Find the eigenvalues and eigenvectors of 1, 3, 4, 5. One minus 3 minus 4, 5. So basically finding this directly is not easy. Okay. So what we do, first step is we find eigenvalues first. And eigenvalues come from a characteristic equation. Okay. First find eigenvalues by solving characteristic equation. The determinant of A minus lambda I is equal to 0. A minus lambda I is subtracting lambda from the diagonal only. Of diagonal elements remains the same. So you only subtract lambda from the diagonal. It means lambda is subtracting from the diagonal only. That's it. Off diagonal elements don't change, equal to 0. So if you take the determinant, it is 1 minus lambda, 5 minus lambda, minus 4 3s are 12 equal to 0. And this will become lambda into lambda, lambda square, minus 5 minus 6 lambda, and minus plus 5. Plus 5 minus 12 is minus 7 equal to 0. So this is called characteristic equation, characteristic polynomial or equation. Okay. Now if I solve this, I will get lambda. So lambda plus 1, lambda minus 7. These are the factors. So lambda equal to minus 1 and lambda equal to 7. These are the two eigenvalues. Okay. So you got the eigenvalues. Once an eigenvalue is given, how to find eigenvector? So in this question, they ask you that a lambda eigenvalue is given. If lambda is equal to 2 is an eigenvalue, find the corresponding eigenvector. So in the question number 2, you don't have to find the eigenvalues. So for eigenvectors now, uh, one by one. So first for lambda equal to minus 1. We have to solve the given equation, right? Ax equal to b, because ax is equal to lambda x was, this is what I had, but I cannot do it at the beginning. Now lambda is given to me, right? So ax minus 1x, basically lambda is minus 1. I have to solve this, or I can write a plus lambda ix, a plus 1x ix equal to 0. So I have to solve this for non-zero x. Okay. So whenever I solve a homogeneous system, I just take this matrix a plus lambda I, a plus 1 I. Just write 1 plus 1 minus 3 minus 4, 5 plus 1. Adding 1 in the diagonal, 1, 5. Right. So this is 2 minus 3 minus 4, 6. So see, if I do these both equations give me the same thing. They both give me 2x1 equal to 3x2. Both from here and from here. Both equations give me the same thing. So if I divide by 2, so it means x1 is equal to 3 by 2 x2, and x2 is free because I'm not getting any second equation. Or what you can do, you can use row algorithm, use this to make it 0. So I can do R2 plus 2R1. If I do R2 plus 2R1, this will become 2 minus 3. So 2 2s are 4 minus 4, 0. 3 2s are 6 minus 6 is 0. See, the second equation has become 0. So now you see it is 2x1 minus 3x2 equal to 0. So this implies that x1 is equal to 3 by 2x2. So x2 is free. So one of the variables have to be free whenever you solve for eigenvectors. So therefore, now if I write the vector is x1, x2, but my x1 is 3 by 2 x2 and x2 is x2. If I take x2 outside, I will get 3 by 2 and 1. So I will just pick this one. This is my eigenvector. Okay. So my eigenvector, usually we write them as V. So 3 by 2, 1. Okay. We are only interested in the direction of the vector. Okay. We are not interested in the length. We can take a smaller length or a bigger length, no problem. So we prefer to get rid of this fraction. It's better not to write this fraction here. 3 by 2 does not look good. So what we do, we take x2 by 2 as common, right? So then it becomes 3 and here it becomes 2. So it's better that you take 3 and 2 instead of 3 by 2 and 1. This looks better. Okay, 3 by 2 and 1 are also the same. 3 by 2, 1 is the same vector, no issues. Here I just multiplied it by 2. If you multiply this by 2, I will get this vector. So multiplication of 2 only changes the length. Okay, only changes the length, so it doesn't matter. So I think we prefer this one. Then redo this thing for the second eigenvalue. Then you have second eigenvalue, which is 6, right? Second eigenvalue was 6. 7, not 6. If you add the eigenvalues and add the diagonal elements, they are always the same. You see, what is the sum of diagonals here? 5 plus 1, 6. And what is the sum of eigenvalues? Minus 1 plus 7, 6. You see, sum of diagonal a11 plus a12 is always equal to lambda 1 plus lambda 2. So see, 1 plus 5 equal to minus 1 plus 7, 6 equal to 6. This is a little check. If you find the eigenvalues, you can have a little check here. Here I will solve for 7, I will solve a minus lambda I. But lambda is 7 now. So a minus 7i x equal to 0 for some non-zero x. Okay. I will solve for x which is not equal to 0. So I can write just a minus 7i, which is just subtracting 7 from the diagonal. Okay. Just subtract whatever is written here. A minus 7i, you can subtract 7 from the diagonal. Okay. Minus 5, minus 3, minus 4, minus 2. Minus 6, not minus 5. So again, these both give you the same thing. You see, the first equation gives you minus 6x1 minus 3x2. So x1 becomes 3 by 6. 3 by 6 minus 1 by 2 x2. And same thing comes from here. 4x1 is equal to 2x2. So x1 becomes 2 by 4, which is 1 by 2. So both gives you the same thing. So it means x2 is free. Okay, so now if I write x vector, x1 is minus half x2 and x2 is free. Now I can bring x2 divided by 2 outside, so I'll get minus 1 and 2. So this means my second eigenvector is just minus 1 and 2. Just pick the vector here. No need of picking this. You can drop it. Just this is your V2. Okay, this is your V1. So these are your two eigenvectors. I can write lambda 1 V1, lambda 2 V2, and so on. So V1 for lambda 1 equal to minus 1, V2 for lambda 2 is equal to 7. So any questions so far? If you have to only verify something is an eigenvector, no need to solve the whole thing. Let's say to verify a given vector V is an eigenvector of a matrix A, right? How to proceed? Just multiply A with V. A into V. Whatever A is given, multiply this with a vector V, right? and see whether it gives you your V back. Any constant outside, that is, of course, we call it lambda, and your V should come back. So if this is true, then yes, V is an eigenvector, otherwise it's not an eigenvector. And if it is true, then you get the eigenvalue from here. Where is that? Let me show you. Look at these questions where a vector is given, a matrix is given, and they are asking you, is this an eigenvector of A? So you will just multiply this A with V. Let's say this is a vector V. Just multiply A with V and see if your V comes back with some number here. Okay, with some number here. If it is an eigenvector, you will definitely get a number here. Otherwise, you don't. The last two topics were complex numbers and vectors. So one question that contains these both. Three parts will be there, plus vector calculus. So in complex numbers, you should know that if a complex number is given a plus iota b, where both a, b are real numbers, then you should know how to find the modulus of z, right? A square plus b square square root. How to find the argument of z, which is the angle it makes with x-axis, conjugate of z bar, which is a minus iota b. You should know the polar form of z, which is z is equal to r cos theta plus iota sine theta, where r is this modulus and theta is the argument. Right? If you can find r and theta, you can just put them here to get the polar form of z. There was uh, how to show a vector on a xy plane. X is always the real axis, y is the imaginary. So the real part A goes here, and the imaginary part B goes here on y-axis. So if you get a point AB, this vector is basically your complex number. Z is equal to A plus iota. And the length of this vector is your R, and the angle that it makes with x-axis is theta. Okay. So if the question is show this complex number on Argand diagram, you can do it like that. Argand diagram. This is exactly the xy plane that we do in calculus. But for complex numbers, they call it Argand diagram. In vector calculus, there were three things that were important. One is the gradient of phi, which is the derivative of phi with respect to x, I, derivative of phi with respect to y, j, plus derivative of phi with respect to z, a. A phi is given, right? This is called the gradient of phi, where phi is given, of course. Phi is a function of x, y, z, and you can find the gradient by just taking the three partial derivatives of. If, and this is a scalar function. There is no ijk in phi. It is a scalar function, okay? Instead of that, if a vector function is given, and this function will be given, right? scalar function, it will be a given to you. Now, if you are given a vector function, let's say f x, y, z, it means it has some f1, a function with I, plus f2 with j, plus f3 with k. If a vector function is given, you can define two things. One is divergence of f, div of f, div, right? Which is del dot f. So we multiply del with del is basically just the partial derivative of x, y, and z with ij, k. So if you take the dot with f, what you do? You take the first one with the first one only. So it means it is partial f1 by partial x. And in dot product, there is no ijk. Then you'll pick the second one, partial by partial y with f2. So it means f2 by y. And f3 with z. No ijk in the divergence. This is your divergence of f. And curl of f, that is del cross f. And you know that the cross product of two vectors is given by I, j, k in your first row, del in the second row. So you know that del is partial by partial x, partial by partial y, partial by partial z, and f in the third row, f1, f2, f3. So you just now you can just find the determinant and get the answer. So if you look at the notes we posted, we have done a few examples. Just concentrate on these few things from these two lectures. No need to go through all of them. Okay. So divergence, curl, gradient. If a point is given, you can replace the point at the end, right? If they say find the gradient at the point, you will first find the gradient and then at the end put the point x, y, z in your answer. And in complex numbers, I think that's enough to find z modulus, argument, conjugate, polar form of z. That's enough for you. Okay. So both the videos are there. Complex numbers and vector calculus videos are there. You can watch them. But only focus on the things that I told you here now. All right. I hope this will give you some idea about the exam. And hopefully this will help you in preparing and answering the questions. All right, so I have recorded the video, so you can watch it later if you want. And people who are not here, they can see that later on. All right, guys. Good luck for the exam. If you have any questions, you can ask.
Thank you, Doctor.
Thank you, Doctor.